Introduction, nanosponges, cyclodextrin, and cross-linker. In the introduction, I will talk about nanosponges, cyclodextrin, and cross-linker. The cross-linker, the nanosponges, firstly, nanosponges. What are nanosponges? Nanosponges are a type of nanoparticles. They are pores in structure, pores being about 1 to 2 nanometer in size. They can be targeted to absorb a small amount of matter or toxin. Nanosponges are drug delivery system which can carry both hydrophilic and hydrophobic drugs. Cyclodextrin, we have three types of cyclodextrin: alpha cyclodextrin, beta cyclodextrin, and gamma cyclodextrin. From their shape, the shape is circle, as a circle, and they have a cavity inside the cyclodextrins. They have cavity. In this cavity, we can encapsulate alpha. We can capsulate the uh, the drug inside it and can be delivered to the target tissue. Cyclodextrin nanosponges characterized by many properties. For example, they characterized by high biocompatibility, prolonged circulation of the blood, uniform size distribution, easy access to the target. When we encapsulate the drug inside the cyclodextrin nanosponges, can access to the target easily. All of these properties make cyclodextrin nanosponges are excellent for use as diagnostic agent. So the most important application of the cyclodextrin nanosponges in the diagnostic agents. The cross-linkers used to link between several cyclodextrin. This is when we want to talk about cross-linker. The cross-linker are used to link between several cyclodextrin. The common example for the cross-linkers are diisocyanates, dicarboxylic acid, alkyl dihalides, acid chloride. This is the common cross-linkers used to link between the cyclodextrin and in order to get cyclodextrin nanosponges to use in the drug delivery system or in the environmental application or in the agricultural application. Methodology. In the methodology, we can talk about the several methods of the preparing cyclodextrin nanosponges, and we will talk about the two common methods. The one method call it solvent-assisted synthesis, ultrasound-assisted synthesis, microwave-assisted synthesis, melting method. But for this is the four common methods, but I will talk about the two of them: solvent-assisted method and melting method. And the melting method is the most common used. And all the papers that I I read about, they are prepare the cyclodextrin nanosponges with the melting method. The census, if I want to talk about the census, I will talk about this picture because this picture summarizes the way of census of cyclodextrin nanosponges. I can bring the cyclodextrin and put it with the cross linker, and I used one of these methods in order to get cyclodextrin nano bonds. Cyclodextrin with the cross linker can get us cyclodextrin nano points as here. This linker can link between this and this and this and this. So this is the method. So I will talk about the first method is a solvent-assisted synthesis. Here in this method, the cross-linker dissolve in the solvents like DMSO, and DMF. So this is the two methods of the cross-linker is dissolved. It used solvent like DMSO and DMF. The polymer is the first treated with the solvent. Firstly, the polymer treated with the solvent, the polymer treated with the solvent. After that, pours into the cross linker in order to get cyclodextrin nano sponges. So firstly, the polymer treated with the solvent. After that, it pours inside the cross linker. So here, this is the cyclodextrin nano sponges with the solvent, and here is the cross linker. So I must pour the I must pour, I must pour, I must pour the crossly, I must pour, I must pour the close linker with the cyclodextrin inside. I must pour the cyclodextrin and the solvent to the cross linker. Melting method. In the melting method, and this is, as I said, this is the most important method, and many papers are prepared by this method. So the cross linker is melted with the cyclodextrin. You must we must bring the so you must bring the cross linker with the cyclodextrin, put them together, and melt them together. All material are homogenized. All the material are homogenized before being heated at 100 degrees centigrade. So here the most important thing is cyclodextrin with the close linker melt together and homogenize together, and put it into the 100 degree centigrade, and 5-minute stir, magnetic stir are used. After then, the mixture is allowed to cool down. When it cools down, that means I prepared cyclodextrin nanosponges. In the application, the most important application for the cyclodextrin nanosponges is drug delivery. This is the most important application because cyclodextrin nanosponges, as I said, it has cavity. This cavity can encapsulate the drug in it. So it can, and it is easy to go to the target tissues, to the target tissues. So when we prepare cyclodextrin nanosponge, that means we have a lot of cavities linked together with the cross linkers in order to uh, to to make a drug delivery to the target inside the body. Other application for cyclodextrin nanosponges in the environment in the environmental measurements, cyclodextrins play a very important role in the environmental field in the solubilization of organic, elimination of the organic toxin and heavy metal from solid atmosphere and water. In the summary, I want to conclude that cyclodextrin nanosponges are a newer version of biocompatible cross-linked polymer. This is the cyclodextrin nanosponge with distinct encapsulation. Encapsulation because it has a lot of cavity, so it can encapsulate. So the encapsulation of non-extreme uh, cyclodextrin resource is distinguished. So also biocompatibility, it has biocompatibility, solubilization properties of numerous types of molecules. Cyclodextrin nanosponges can be used in a variety industries, include pharmacy, medicine, agriculture, cosmetics, and the environment. And this is the future work, inshallah, because of the environment we have a lot of contamination in the environment. So the cyclodextrin nanosponge or the nanosponge, any type of nanosponge can capture the toxin of the environment or any contamination in the pollution area. And thank you for listening